Okay, let's go answer letter C. This is problem chapter 9, number 94, letter C. What is the average rate of change for each function over the interval between 1 to 2? So in our table, okay, let me show you our table. We are looking for rate of change. Remember, rate of change is the slope of the line. That's the vertical change over the horizontal change. So between 1 and 2, we're looking for 1 and 2 intervals of x. So we'll be using 3 and 1, 2 and 1. So when you talk about average rate of change, okay, let me use my blue one. So the average rate of change is the same as our slope. So when we get our slope here, we are getting the y value. So from 3 and 1, so that's 3 minus 1 and 2 minus 1, because we're getting the value of x at between 2 and 1. So this is equal to 3 minus 1 is 2, and 2 minus 1 is 1. This is equal to 2. For g of x, okay, we are looking for 1 and 7. So this is between 1 and 2. So we have 7 and 1, 2 and 1. So again, that's 7 and 1, 2 and 1. So our average rate of change would be 7 minus 1, 2 minus 1. There will be 6 over 1. That's equal to 6. And for h of x, so our h of x will be between 2 and 1 again. That's 3 and 1, 7 and 1. 3 and 1, 2 and 1. So our slope here is 3 minus 1, 2 minus 1. That's why we have 2 over 1, which is 2. Now if you're going to get the second interval, which is 2 to 3, so this is 2 to 3. For f of x, we're looking for this. So our m here would be again, that's 5 and 3, 3 and 2. So 5 minus 3 over 3 minus 2. So that's 2 over 1. Again, that's equal to 2. For the next interval, the g of x will have 17 and 7, 3 and 2. So we have m is equal to 17 minus 7 over 3 minus 2. That's 10 over 1, which is 10. For our h of x, okay, that's 7 and 3, 3 and 2. So our m is 7 minus 3 over 3 minus 2. Therefore, we have 4 over 1, which is equal to 4. Okay. So that is the interval. Now, how do you answer parts B and C relate to the order of finish in the race of infinity? I answered this already, and I would like just to show you the answer here, okay, in our previous video. Okay, so just to show you the answer for race to infinity, that would be due to the growth of rates of quadratic and exponential function increase, they will always beat the linear function. So we know that quadratic and exponential will always be moving forward compared to the linear function. But the average growth of rate of the quadratic increases, but the increase is by the same amount each time. So as you can see, the increase is 2, 6, and 10 from our previous example. 2, 6, 10. So 2 between 2 to 6 is 4. 6 to 10 is also 4. So the amount of increase is the same amount each time, while the exponential rate of change increases by multiple of 2 each time. Okay, so each time for our h of x, it's a multiple of 2, the power of 2 each time. That's why we say that our exponential rate is going to win in the race of infinity. So this is the last part of our answer.